to know every prime number between 1 and 100, your child does not need to learn every prime number between 1 and 100. There's a strategy for finding them quite quickly. The only thing your child will really need to know is how to find a multiple of 3, and to know their 7 times tables, but a little bit further than 7 times 12. In fact, if they can learn right up to 7 times 13, which really means we only need to know one more number, then your child will be able to identify which numbers are prime and which numbers aren't. A prime number is a number with exactly 2 factors. That's 2 numbers that fit into it. One of those numbers will always be the number 1. The other number will be the number itself. Now, the number 1 is not a prime number because it only has one factor, 1. It has to be 1 and something else. So the very first prime number is 2, and it's the only even prime number. The next prime number is 3, then 5, and then 7. And those are the only 4 that your child really needs to learn. 2, 3, 5, and 7. Because from then on up to the number 100, all your child needs to think about is this. If the number is a multiple of 2, in other words, if it's even, it's not prime, apart from 2. If it's a multiple of 3, apart from 3, then it's not prime. If the number is a multiple of 5, and really by now we're only looking at numbers that will end with the number 5 because we've already eliminated all the numbers that end with 0 when we eliminated all the even numbers, it's not prime either. So the only number that ends with 5 that's prime is 5. And then, if it's a multiple of 7, it's not prime. So I'm going to cross out on this random list of numbers here. There are other prime numbers, but in this random list of numbers between 1 and 100, I'm going to eliminate all the numbers that are multiples of 2, 3, 5, and 7, and the numbers that are left will be prime. So the easiest place to start is the 2's by eliminating the even numbers, but I'll also eliminate any number that ends with a 5. So that has dealt with all the 2's and all the 5's. Now we've got to think of the multiples of 3, and some of you, when you were at school, maybe learned a trick that I learned as well, and that is we can identify any number that's a multiple of 3 by adding the digits together. And when you add the digits together, you'll get another simpler multiple of 3. So as long as your child knows the 3 times tables up to 30, then they'll be able to use this strategy. I'll show you what I mean. Well, 21. Hopefully they already know that 21 is a multiple of 3. But if you check the digits, it's 2 and a 1, and 2 plus 1 makes 3, which is a multiple of 3. So 21 is not a prime number because it's in the 3 times tables. And then you could start adding digits together, like 29 is 2 plus 9. That makes 11. 11's not in the 3 times tables. But hopefully your child already knows that since 30 is a multiple of 3, then 29 can't be. Then we've got 37, but that's a 3 plus 7 that makes 10. 10's not a multiple of 3. 3 plus 9 makes 12. 12 is a multiple of 3. So 39's a multiple of 3. 39 can't be a prime number. It's in the 3 times tables. And the next one that we'll come to that makes a multiple of 3 is 51, because 5 plus 1 makes 6. So we'll eliminate 51. So that deals with the 3's. We only need to think about the 7's. Now, we've already probably eliminated most of the 7's, but 1 or 2 might still be hanging around. For example, 77, which is 7 times 11, or 49, which is 7 squared. But there's one left on this list that your kids maybe don't know about, and that's the number 91. Now, if your child knows that 7 12's make 84, then if you take 84 and add another 7 to it, you will get 91. So this is the answer to 7 times 13, and that's the number that traps most kids whenever they are identifying prime numbers. So that deals with the 7's. Everything left on this page that hasn't been crossed out is a prime number. So 11 is prime, 29 is prime, 37, 43, 59, 61, 71, 83, and 97, which is the only prime number in the 90's. For a bit of practice for your child, you could print out a 100 grid. That's a grid that goes from 1 to 100 in lines of 10s, and then get them to cross out every number that isn't prime. Anything that's left should be prime, and there should be exactly 25 prime numbers from 1 to 100.